Hello everyone, hope you're well, and I'm going to start another video of on series of GCSE Maths on following previous videos on numbers, least common multiple and highest common factors. The subject that I am going to cover today to have some initial concepts and definitions of this is fractions. And fractions, as you know, we show it with a number at the top. As an example, if I just call this 1 over 2 in here, this 1 at the top is called numerator, and the number at the bottom under the line is called denominator. And fractions in daily life we associate it with proportion. So when we say half of a something, we mean 1 out of 2. So 1 out of 2 of a specific thing or a unit. So to just have some sort of visual idea of the fractions, I have set these circles in here, and if I want to say 1 out of 2, I can basically divide this circle to half, and if I then color this circle in this area, the colored area basically showing 1 out of 2 of the circle. So if I call this is basically one section, and this is another section, this the colored area is 1 out of 2. In the same way, if I go to the other fractions that we have in here, 1 over 3, what I need to do is to divide this circle to 3 equal sections. So I am going to try to do that. And if we consider that as equal section, when we say 1 out of 3, we just need to color just one section out of this 3 in here. The part that is, and in a way, when we say 1 out of 3 or 1 out of 4, we can always assume that 1 out of 3, it is same as saying 1 divided by 3. So this line in here, or in fraction to make a fraction, that is a similar concept to a divide. So we will cover more about that later when we have the applications related to that. What I want to cover in here is about cancelling down or simplifying fractions. So if I come back to my the first one in here, which I had colored about 1 over it was 1 over 2. If I divide this to 4 equal sections, and basically what you can see now, so I can also, for the area that I have colored in here, which is this section, I can see that this area is 2 out of 4 as well. So we can basically, this is 2 in here out of total of 4. So we can basically do 2 over 4. And in the same way, for the one that in here, which is 1 over 3, if I divide each one of those 3 again to another 2, I can now see that the colored area, I can write it 2 over 6. So 2 out of 6. So how does this work? And in algebraic format, I just wanted you to visualize that. We can write that 2 over 4 equals 1 over 2. We can even continue if we want to write it that is equal to 3 over 6 and equals to 4 over 8. And a simple rule in here is that we can always time or divide both denominator and numerator of a fraction to a specific number, and that fraction would still be the same. So in 2 over 4 to 1 going to 1 over 2, basically what we did, I can a bit erase that section. I can say that we did divided by 2 and divided by 2. From 1/2 to 3/6, we did times 3 and times 3, and it just goes on. However, we show the fraction with its simplest form as the time that the numbers are smallest, and we cannot simplify it even more. So just coming to this 4/12, if I divide both of the numbers to 4, I get to a value of 1/3, and that 1/3 is the most simplified form, and we will basically we cannot simplify this any further, and we normally keep the fractions and the final answers in that simplified form. And finally, I have 18/48. I can divide both of them to 6. If I divide it by 6, this would give me dividing by 6, and that would give me 3/8. And again, I cannot divide this any further to reduce the number to value of the numbers. But how we can find out what is the best number to divide? The 6 in here is the highest common factor between 18 and 48. So 6 is highest common factor between 18 and 48. So we have had a video about how to find the highest common factor. So if you find the highest common factor and divide to that, you will get to the most simple form of a fraction. But if you did not want to find the highest common factor, you can always do this in steps. So 18/48, if you don't know that you can divide it to 6, you can see that you can divide it to 2 because they end up with the even numbers. So dividing by 2 would be 9/24. This time 9 and 24, you can't divide both of them to 2, but you can divide both of them to 3. So if I divide both of them to 3, I will get to 3/8. So you could do it on through some steps with the smaller numbers, or you could find the highest common factor and make it one step. Finally, in this page, I'm looking at this numbers axis just to show the fraction. So we have a 0, 1, 2, and 3, and -1. And when we talk about half is showing somewhere around here. So this is over half. And if we are looking at 1/3, or 1/3 could be somewhere around here. That could be around 1/3. But what I wanted mainly to show in this one here is that fractions, they could have also a negative sign, same as numbers. So if I wanted to say -3/4, I need to go into a minus direction. So from 0, -3/4 would be somewhere around here, -3/4. So if I divide this like this, so that is showing -3/4. So we will deal with this minus value of the fraction exactly in the same way that we deal with numbers. So if we are timing them, positive times minus, or minus times positive is a minus, and minus times minus is positive, positive times positive is positive. And if we are subtracting or dividing, subtracting or adding, again we'll deal with them same as numbers, and we come back to that with some examples in the next few pages. Okay, in this page we're looking at mixed numbers, and what we mean from mixed numbers is a mixture of integers and fractions. And I have put some of the mixed numbers in here, and it is, for example, I can basically see I have 1 and 1 over 2, 2 and 3 over 4, and minus 4 and 1 over 3. And what that basically means, say 1 and 1 over 2 means that I have 1 unit, full unit, and from the second one I just have half. So in a way, in a normal conversation, we say 1 and half. And what we see in a math, in mathematics, we show it by 1 and 1 over 2. Now then 2 and 3 over 4 means we have a 2 complete unit, and then we have a 3 over 4 or 3/4 of a unit from plus that 2. So as you can see, these basically mean 2 plus 3 over 4, and that 1 and 1 over 2 means 1 plus 1 over 2. And for the last one, which is minus 4 and 1 over 3, that basically means minus 4 plus 1 over 3. And as you can see, I need to put a bracket there just to show that minus is for whole of 4 plus 1 over 3. If I want to show the 1 and 1 over 2 on the axis in here, so this I can basically show it from here, from 0, so 0 to half, this would be 1 and 1 over 2. And if I want to show 2 and 3 over 4, this would be 2 complete units and 3 over 4. So somewhere around here is 2 and 3 over 4. And the same thing, if you want to show the minus, this we have to go in a minus direction, 4 units, and then 1 over 3. Now I will come back to this mixed numbers later, but before that I need to go through some other basic points about fractions. So one of those basic units is adding and subtracting fractions, or then what is in here is a concept of common denominator. So we can only add or subtract fractions when they have a common denominator, and in a way they are of the same proportion. So what does that mean? So if I want to add 2 over 5 and 1 over 5, they have the same proportion. So what does it mean? So this basically means that my circle is basically divided to 5 sections, and I'm going to do that for the other one too. So now one of these circles is 2 over 5, so I have 2 over 5, and the other one is 1 over 5, which is in here. So if I add these together, what I will have is basically adding one of those portions to this one in the left. So it's like I am adding one more portion. So what is left in here? So I have, if I look at this addition now, I have 3 out of 5. So that is why when we add, we keep the denominator and we add the numerators together. So that would be 2 plus 1, and that would be 3 over 5. So if I clear this section now and look at basically the second example. The second example is 2 over 5 minus 1 over 5. So we are saying that this is minus the 1 over 5. So if you want to minus, it means that we need to take one part off. So that taking one part off, it means that I need to clear that. So what is left after that, as you can see, is just 1 over 5. So again, the denominator is the same, but at the top we have the numerators minus with 2 minus 1, which is 1 over 5 as an answer. So if I come in here and basically try to do another example which we don't have a common denominator. So the example that I can see in here is this example of 1 over 2 plus 1 over 3. So I'm just going to again divide these. 1 over 2, so this would be 1 over 2 in here. And then that is plus 1 over 3. So 1 over 3 in here is somewhere around here. So this is that, and 1 over 3 is one of these sections. So if I want to add up these, I don't have any sort of visual understanding of how that can be done because the portions are different. As you can see, this is this portion in here in the left. This portion is a completely different portion from the portion that we have in the right. So that is why we cannot directly just add up these two fractions together. So we have to use a trick in here to go through that this issue. So what happens if I come and divide this to basically 6 parts, and I do the same for this? Now, the one thing that you can see by doing this, I have now 2 parts, 2 units, that each one portion is exactly the same. So I can say that, for example, this portion here is equal to this portion here. But what is interesting is that in the previous one, now the amount of the part of the unit that we have is basically 3 over 6. And on the second one is 2 over 6. And we have basically made these portions proportional so that we can add them up. So 3 over 6 and 2 over 6, and if we add them together, same as above when we had the common denominator, basically the answer would be 5 over 6. But okay, this was based on that graph, or how we can do this without visualizing that, and also for complex problems, because this is the example for simplified version, just for us to see what is happening visually on when we add or we subtract fractions. But what happens, or what we need to do if we have a more complex problems? So we need to create basically a common denominator between 1 over 2 and 1 over 3. The denominator of 1 over 2 is 2, denominator of 1 over 3 is 3, so denominator is the one at the bottom of the fraction. So I can say that 1 over 2 is equal to 2 over 4, equal to 3 over 6. I can time it to 2, time it to 3. If I time the numerator and denominator both, it is the same fraction, equals to 4 over 8. And that continues 5 over 10 and continues to more of fractions. And I can say that 1 over 3 equals 2 over 6 equals 3 over 9 equals times 4, 4 over 12, and that equals, again, goes on and on. So if I look at these two and compare these two together, I can see that this 3 over 6 and 2 over 6, they have the same denominators. So to get to a common denominator, I can put, instead of 1 over 2, I can write 3 over 6, and that would be plus 2 over 6, because I am just putting their equivalent. So it is important that you consider that in math we have to follow a logical path, and when we follow that logical path is when we put an equal, we have to make sure that we logically put something that is equal to the left hand side. So we just put the equal of 1 over 2, which is 3 over 6, plus equal of 1 over 3, which is 3 over 6, plus equal of 1 over 3, which is 2 over 6. By doing this, we have a common denominator. Then we can keep the denominator and say 3 plus 2, and the answer would be 5 over 6. And as you can see in here, we have 2 in here and 3 in here. So in total, 5 out of 6 when we add these two fractions. So that is a way of getting a common denominator. But another way and more straightforward way is that for common denominator is that common denominator is the least common factor of two numbers. So we have had a video about how to find the least common factor of two numbers. It is easier when we have 1 over 2 or 1 over 3, but when we have larger numbers, it is important that we are able to find the least common factor. So I forgot to put the common in here. So least common factor of two numbers. Okay, for simple cases like this, we could find that, okay, 1 over 2 and 1 over 3, I can write 1 over 2 as a 3 over 6, and then 1 over 3 as a 2 over 6, and then we have a common denominator, which gives us 5 over 6. Now, for complex numbers or larger numbers, it is difficult to go like this and find each one of the cases and find out the common denominator. But a more easiest or streamlined way of finding what is common denominator is that common denominator is least common multiple of two numbers. So in here, 6 is a least common multiple between 2 and 3. So least common multiple. So what I am going to do in here to go and do the other two examples in here based on finding a common denominator, based on finding a least common multiple of two numbers. So I come to the next example, which is 5 over 6 minus 7 over 9. If we look at this, the least common multiple of 6 and 9 would be 18. So I'm going to write this 18 in here. So that is the least common multiple of between 6 and 9. Now, because as I said, the math is a logical process. So when we add this equal in here, we need to make equal fractions. So 5 over 6, what is equal to that in terms of having 18? So we see that the 6 is times 3 to give us 18. So we need to time the numerator also to 3 to give us 15 to make that 15 over 18 is equal to 5 over 6. So we need to put an equal value. The same thing applies for the second one. So 7 over 9, 9 times 2 is 18, so we need to do 7 times 2, which is 14, to make an equal fraction. So when we write this in here, we have put the equal to 5 over 6 minus comes as it is, and then equal to 7 over 9, which is 14 over 18. And the answer in here would be 18, and 15 minus 14, and the final answer is 1 over 18. Okay, now we are going to do the final example. The least common multiple between 27 and 36. 27 is 3 times 3 times 3. 36 is 2 times 2 times 3 times 3. And we know that this is prime factors. We know that the least common multiple is basically everything and with a shared area just repeated once. So we would have 3 3s and 2 2s, so would be 27 times 4, and 27 times 4 would be 108, so that would be 108. Now that we have found the least common multiple, which is a common denominator, now we need to make this work. So when we call equal, we need to write the equal of 4 over 27. So 27 times 4 gives 108. So we need to do 4 times 4 to give us 16, so that we have put the equal of 4 over 27. 36 times 3 becomes 108, so we need to put the equal of 5 over 36, that would be 15. So this would be, if we add them together, would be 31 over 108. And we cannot simplify that anymore, so that would be the final answer. Now, we go to the next page. This page is about multiplying and dividing fractions. Multiplying and dividing fractions is generally easier than adding or subtracting, because we don't need to find a common denominator. So why is that we don't need to find a common denominator? So if I look at here, the first example, I put a simple one so that we are basically visualizing again what's happening. If I find out, if I just put 2 over 5 to show visually what is 2 over 5. So 2 over 5 visually would be something like this. And we have 2 parts of it selected, 2 out of 5. So if I want to say half of that, so when I say half times 2 over 5, that basically means half of 2 over 5. So half of 2 over 5 would be just half of what we have. So that would be this section. And that green section basically represents 1 over 5. How we find that into in algebraic format, we say that when we have times of multiplication of 2 fractions, we time the numerators to numerator and denominator to denominator. So this would be 1 times 2 and 2 times 5. And that answer would be 2 over 10. If we simplify, divided by 2 both sides, 1 over 5, which is the answer that we got on the basically our circle. Now the next one is about 2 over 5 divided by half. 2 over 5 divided by half. So what that basically, again, visually what that means, if I just again put a 2 over 5 in here, so this is about 2 over 5, and I'm going to color this section, that is 2 over 5. When you say 2 over 5 divided by half, basically what we are saying what is 2 over 5 out of 1 over 2? So what is the 1 over 2 of this unit? So 1 over 2 is about, if I put this line and straighten this up, that would be 1 over 2. And this section would be 1 over 2. So if I look at the fraction of the colored area out of that 1 over 2, it basically means that I have this area which is colored out of the half of this. So I can just completely forget the top part and just look at the bottom half of this circle. So how we get the answer is that because this is 5 and we are dividing that unit, we can also do the same divide in here and here. So in here we have 1, 2, 3, 4, and 5 same parts. And when we say this colored area out of half of this has 5 of these, and the colored area is 4. So the answer is 4 over 5. And how we get to the answer in here algebraically is we just say 2 over 5 times reciprocal of the second fraction. And when we say reciprocal, it means that the denominator and numerator, they change places. So that would be 2 over 1 and times 2 over 1, just changing places. And then the rest would be the same as timing two fractions. So that would be 2 times 2 divided by 5 times 1, which is 4 over 5. As you can see in here, in none of these two, we needed to find least common multiple. We did not need to find a common denominator. So common denominator, you will have to do the common denominator only when you're adding or subtracting fractions. Now, I'm going to look at the next few examples. So this would be 4 times 2, which is 8. 3 times 5 is 15. So, and that would be the final answer because I cannot simplify it further. Now, 5 over 6 divided by 7 over 9, I would put 5 over 6 times reciprocal of the second fraction, which is 9 over 7. So that would be 45 divided by 42. This can be simplified. Both of them are divisible by 3. And if you want to ask why they are divisible by 3, you can count the digits in here. 4 and 5 is 9. 9 is divisible to 3. Therefore, 45 is divisible to 3. 4 and 2 is 6, divisible to 3. Again, therefore, 42 would be divisible to 3. So dividing by 3, that would be 15 over 14. If we wanted to write it in a mixed format, we can just write it 1, because 14 over 14 would be 1. What is left would be 1 over 14. Okay. And finally, we come to the final example here on this page, which is basically say 4 times 5 is 20. And then you have 27 times 36. If it is a non-calculator exam, and if you want to time the 27 times 36, that would be a bit of longer process and time-taking process. And after that, you will find out that the number is 972. And then you need to simplify this, because at least we can see that this is divisible by 2 both sides. If I divide it by 2, that would be 10 over 486. Again, divisible by 2, that would be 5 in here. 5 divided by, that would be 243. And that would be the final part, because you cannot simplify this anymore. So this is a it will be a long, you have to spend a longer time to do this, because you have to manually on paper do 27 times 36, and then you need to manually simplify these cases. A better solution with these cases is that we can completely just start from beginning and see how we can do this more effectively. As we know in here, we know that this is basically 5 times 4, and this is 27 times 36. We can simplify this just right here. We don't need to time everything and simplify. This 36 divided by 4 would be 9. 4 divided by 4 would be 1. And can we simplify further? We can't. So that would be 1 times 5 would be 5. 9 times 27, that is 63, and 180, that would be 243. So it was much easier timing, so just timing 27 times 9 rather than 27 times 36 with just small simplification of 4 divided by 36. Because this is time, you can even simplify it in here and divide by 4, that is 1, divided by 4 is 9. So you can just do it right there, even you don't need to write the second part. So definitely you need to practice simplifying as much as possible before timing numbers, because that would reduce the size of the numbers and that will save you time in the exam. So the next page is about adding, subtracting, multiplying, and dividing mixed numbers. The only thing that we need to do when we have a mixed numbers is that we need to convert the mixed numbers to normal fractions. So we need to convert the mixed numbers to normal fractions. So I did, for example, mention that 2 and 3 over 4 is basically 2 plus 3 over 4. Or minus 4 and 1 over 3 equals minus, inside bracket, 4 plus 1 over 3. One way of converting a mixed number to a fraction is to solve and find out this addition. So to find out that 2, I can make it a fraction by adding over 1, because any number over 1 would be the same number, plus 3 over 4. Common denominator between 1 and 4, and in a way least common multiple is 4. So this would be 4 plus 4, and 1 times 4 gives 4, 2 times 4 would be 8, and then this is 3 as it is, and the answer would be 11 over 4. And we could do the same thing for the second one. So we need to do minus bracket, keep the bracket. We need to keep that logical flow of every element and every term going when we do this parts. Minus bracket, 4 over 1 plus 1 over 3, and equals again minus bracket. Common denominator is between 1 and 3 is 3. This common multiple. 3 divided by 1, or what is time? 1 times 3 becomes 3, so 4 times 3 is 12. And 3 divided by 3 is 1, so 1 times 1 is 1. And final answer would be, minus 13 over 3. And we have the minus there. Another maybe quicker way of converting these is like this. So you have 2 and 3 over 4 equals, you keep the 4 denominator. For numerator, you're going to write 2 times 4 plus 3. So you need to look at here, then the integer number times denominator plus the numerator. So 2 times 4 plus 3, that would give us 11 over 4. I can do the same thing for the second example. So minus 4 and 1 over 3 equals, I can write the denominator. I can also write the minus because it's a minus number, minus fraction. So again, 4 times 3, integer number times denominator plus numerator. So 4 times 3 plus 1, which would be 13, which is the same answer. So you need to get used to this conversion. This is easier than trying to add the fractions. So the rest of examples in here are same. We only need to convert them to fraction and do the rest as a fraction. So if we convert the first one, 2 and 4 over 3, that would be 2 and 4 over 3. Okay, this could be even 3 and 1 over 3, but as it is, that would be 2 times 3 is 6 plus 4 is 10. So 10 over 3 plus 3 over 5. And the common denominator here is 15. So I can just write all of it in one go rather than having several times, writing it in. I'm just reducing the number of terms that we need to do these things. So I'm just going to write one fraction, 15. 15 divided by 3 is 5, times 10 is 50. And 15 divided by 5 is 3, times 3 is 9. So you have 59 over 15. So all we are doing, we are just converting the mixed numbers into fractions first, and then we just do a manipulation, either plus adding or timing or dividing. So this example in here, 2 times 24 is 54, 50 plus 4 is 58 over 27, times 5 times 16 is 80 plus 3 is 83, divided by 16. As I mentioned before, we need to simplify as much as possible. So 16 can be divided by 2, which is 8, and 58 divided by 2, which is 29. So the rest of this, I don't see any number in here that can be simplified between the numerator numbers and denominator numbers. So the rest of that needs to be basically calculated. So that would be 2,407 divided by 8 times 27 is 216. And that cannot be simplified further. And the last one is, we are looking at 17 over 16 divided by minus 16 over 9. I can basically say that we write the first fraction, again on a divide version, time the reciprocal of the second one. I can put the minus still there, minus 9 over 16. As same as other multiplication, if you have a positive times a negative number, or same for fraction, that would be a negative. And in here we have 16 times 16, and then we have 17 times 9. Again, this is not, you cannot simplify this, so the answer would be 153 divided by 256. Okay, now if you go to the next page, I think I did go to 2 pages. So okay, coming back to the next page, which is some tips. The last example that we did, we had a negative fraction. This is always a bit of confusing for some of students. Do we have minus 3 over 5, or minus 3 over 5, or 3 over minus 5? There is no difference whatsoever with how we write these. So all 3 of them are exactly the same. And the reason that they are same, as you remember, I said that the fractions are a 3 over 5, for example, is 3 divided by 5. So if I just write minus 3 divided by 5, this would be minus 3 divided by 5. And the last one would be 3 divided by minus 5. As you can see, and all of these, because we have a positive and a negative in a division, the final answer would be a negative number and a negative number. And this is already the final answer is a negative number. So all three of them are same. So don't be confused, because these are basics for algebra. In later videos, when we have different cases, we might have a case of 1 over x minus x. And we should know that this basically is 1 over x, is the same thing. And all of this comes from this basic understanding of the fraction concept. The second thing that I have seen students struggle sometimes is when we have an integer manipulation with a fraction. So the examples that I have put in here is 2 times 5 over 9 and 2 divided by 5 over 9. What students they forget, and sometimes that happens, is that any number we can write it in the form of a fraction. So this is 2 over 1 times 5 over 9. And then the rest similar rules apply. So this would be 10 over 9 at the end. So any number, we can say that 2 equals 2 over 1. 11 equals 11 over 1. Or any number is equal to the same number divided by 1. In this way, we make that integer number in the form of a fraction, which then we can apply our fraction rules. The second example is 2 over 1 times the reciprocal of the second part, which is 9 over 5. So the answer would be 18 over 5. The answer is 18 over 5. How to convert this 18 over 5 to a mixed number? We know that 18 over 5, we can write it 15 plus 3 divided by 5. I chose 15 plus 3 because I know that 15 is divisible by 5. So I can separate this 15 over 5 plus 3 over 5. So we are just doing almost reverse of what we did when we were adding two fractions. And this would be 15 over 5 is 3 plus 3 over 5. And if I write it down in a mixed format, it would be 3 and 3 over 5. This was how we showed a mixed number. Okay, the final tip that I want to look at here is simplify as you go, as I mentioned before. If you have a fraction like this timing, and if you don't simplify, you have to, in a non-calculator exam, you have to time 24 to 14 and 49 to 15, and then simplify those large numbers to get to a final answer, which would take you some time. We can do much more easier when we simplify. In here, I can simplify this 14 either with 24 or with 14. So I can simplify 49 either with 24 or 14. Because it's a time, so if it is a time, I can simplify the denominator and the numerator. So we cannot simplify it as plus adding or subtracting, but we can simplify when it's a time. So if I look at here, 14 divided by 7 is 7. So 49 divided by 7 is 7, and 14 divided by 7 is 2. And then I can look at here, 15 divided by 3 is 5, 24 divided by 3 is 8. And I can't simplify any further. I can't simplify 2 with any of 7 or 5, or I can't simplify 8 with any of 7 or 5. So the final answer would be 8 times 2, which is 16, divided by 7 times 5, which is 35. This is much more simpler way of solving this than directly timing those numbers and trying to simplify a large numbers after that. Okay, my final page in here is about fraction of something and expression as a fraction. So we are familiar with some expressions in day-to-day life when we say half of 6 or a quarter of 20. And this happens in different cases, when we buy some specific portion of something, or when we are talking about a specific portion of different cases or different numbers of people. So when we say half of 6, what does that basically mean? We simply know that half of 6 is 3. But how does that translate to a mathematical form? So half of 6 is half 1/2 of 6. And if you look at it, it's basically equal to half times 6. Because we can give this 6 over 1, and the answer would be 6/2, which is 3. So when we say half of 6 is 3, which looks very easy, the mathematical method around that is that we need to do half times 6 to get to a number 3. The reason that I start with this simple examples is that maths is about understanding these simple cases and extending to a larger, more complex problems. So in a way, if we say 5/12 of 144, that basically is 5/12 times 144. If I put over 1 for that to make it fraction, so that we really are familiar with that, how we are going to time these fractions. 12 and 144 simplified. This is divided by 12 is 1, divided by 12 is 12. So the answer would be 5 times 12 is 60, divided by 1 times 1 is 1, which basically is 60. So 5/12 of 144 is 60. Now, second part is about how to express a number as fraction of another number. So for example, the question could be, write down 180 as a fraction of 80. So 180 as a fraction of 80. So as a fraction of 80, we need to divide that number to the one that we are going to write the fraction against. So that would be 180 divided by 80 as a fraction of 80. And again, we need to simplify this. I can see that they're both divisible by 10, so divided by 10 would be 18/8. They're both divisible by 2. This would be 9/4. So 9/4 is the simplified form of calculating 180 as a fraction of 80. So okay, in this page I put some very few practice questions, and these are GCSE level 3 to 4 in the new GCSE syllabus, and you could pause the video in this point and try these questions, and then I will solve, and you could compare your results with the answers here. Okay, coming back in here, calculate these values, one subtracting and the other one is a division. So we're looking at this mixed numbers. We need to convert to fractions, so that would be 17/3, 5 times 3 plus 2, 17/3, minus 3 times 5 plus 1 is 16/5, and that is, then we need to find out a common denominator, which is between 3 and 5 is 15. 15 divided by 3 is 5, times 17 is 85, minus 15 divided by 5 is 3, times 16 is 48. And the final answer is 37 over 15. And then we can convert it back to the mixed number. We can write 30 plus 7, because again 30 is the highest number within 37 that is divisible to 15. So if you separate this one from each other, that would be 30 over 15 plus 7 over 15. 30 over 15 is 2. So the final answer is 2 and 7 over 15. Now, for this second one in here, again, we need to convert them to fractions. 7 times 15 is 105, plus 8 is 113, divided by 15 times. Now, 4 times 4 and 2 over 5 sorry, just first of all, it's not times. I'm just going to correct this. It's a dividing by 4 and 2 over 5. 4 times 25 is 100, plus 2 is 102, divided by 25. So this would be 113 divided by 15 times reciprocal, 25 divided by 102. Again, simplify as much as you can before you time. This divided by 5 is 3, this divided by 5 is 5. And I don't think that we can simplify this anymore. So I'm going to time this in here. So this would be 565 divided by 306. So this can be again written in a mixed format. So 565, the largest number within 565 that is divisible to 306 is the 306 itself. So that would be 306 plus 259 divided by 306. And the final answer, if we do 306 divided by 306, basically is 1. So the final answer would be 1 and 259 over 306. The final question in here says Jane has 40 chips. 3 over 8 of her chips are red, and out of red chips, 1 over 3 are square. How many chips are red and square? So, first of all, we need to find out how many number of chips are red. So we have 40 in total, but 3 over 8 of them are red. So red, so the number of red, in here would be 40 times 3 over 8. And that is basically 40 over 1 times 3 over 8. Again, we can simplify this in here before timing. Divided by 8 is 1, divided by 8 is 5. 5 times 3 is 15 over 1, which is 15. So out of 40, 15 of these chips are red. The rest of question is 1 over 3, it says, and out of red chips, 1 over 3 are square. So we have 15 red, and out of red ones, we have 1 over 3 of them are square. So to get a red and square, we need to do 15, which is number of red, times 1 over 3, which is square. 1 over 3 of the red ones are square. So that would be 15 times 1 over 1 times 1 over 3. Again, this simplifies, divided by 1, divided by 3. 3 is 1, divided by 3 is 5. So the final answer is 5. So 5 out of 40 initial chips are red and in the same time are square. The important point about this final question and this sort of text type questions is that you need to read the question carefully. Always, if you don't know what to do with this sort of question, you do go and start reading the question slowly, and be careful that every one sentence or small sentence or some information possibly missing that you can't do and progress in solving that question. So that's important to read the question carefully and repeat reading the question. I hope this video has been useful. In future videos we will continue with more of basic fraction, converting to decimals and converting to percentages, and following the rest of GCSE syllabus, the new GCSE syllabus. For more videos and information, you can subscribe to the YouTube channel or visit the website mathsraven.com. You can also have a free online level assessment now in the mathsraven.com website. It's a very sort of online, automatically designed sort of set of a quiz type test that you go through it, and at the end you will find out what is the current level, your current level for GCSE Maths. And thanks for watching this video. I hope that it has been useful.